Hello everyone, my name is Nirmal Kumar Maisuriya and I'm doing my Masters of Engineering in Carleton University. Today I'm going to cover my presentation about flood resilient payment. Actually, I have prepared this presentation for one of my course, Sustainable and Resilient Infrastructures. So let's get started. So these are the main topics I'm going to cover in this presentation. So I'm going to talk about why we need the flood resilient payment, what are the assessment on the flood affected payment, how we can link between payment and resiliency, and how we can define flood payments flood resiliency, how we can improve the payments flood resiliency, and conclusion and references. So why we need a flood resilient payment? So in the past there are severe disruptive events of flooding is happen, and those are the lesson learning for us. In 2005, in the United States, hurricanes Katrina and Rita, due to this event, 3,000 kilometers roads are submerged for the 5 weeks, and that cost $50 million for the rehabilitation for the 200 miles road. Later on, few researchers have worked on that payment, and they have identified that what's going on in this payment after the event, and they have found that the deterioration rate of the payment is rapidly increased. The modulus resilient of the payment is decreased for the flexible payment compared to rigid and the composite one, and structural number is reduced for the bituminous layer. There are two similar incidents happen in Australia as well as in United States, but the most severe one is in Australia for the consequences of flooding in 2010 to 2013 that cost $6.4 billion to Australian government to construct 8,000 round kilometers of road, 1,700 round structures, and other earthwork, and to debris cleared. In the United States, the rehabilitation and the operation cost for this disaster or recovery cost is $63.47 million, and later on few researchers identify that the elastic modulus is drastically reduced after this incident. So what are the assessment are required for the flood affected payment, and what are the use of it to develop so we can develop the RD models from that? And it is also important to understand the payments behavior of the flood affected payment for the further analysis and assessment. So it is important to understand the performance indicators which are used to evaluate the impact of flood affected payment, and most of the researchers has used this performance indicator to evaluate the payments resiliency. So roughness rating are the very common, and the structure numbers, deflection, most of them are interconnected. So moving on, in 2018, Sultana emphasized more on the importance of having a good data set in order to create the RD model or develop the RD model later on and analysis purpose. So roughness data, rating data, and the FWD deflection data is really important. So we can have those data just after the flood events happen. And it is also important to have those data before the event happen. And it is also important to understand the type of distresses in the payment after the flooding. So let's moving forward to understand the road deterioration model with having a different performance indicators. So in 2016, Sultana introduced RD models with performance indicator structure number. In 2018, the same author introduced two different models with a different performance indicator like rutting and roughness. And he also introduced a framework to develop those models. So actually this methodological framework is important for the road authorities to make a effective decision for the pavement rehabilitation and overlay, like which treatment is better to treat the or rehabilitate the flood affected pavement. In 2014, Khan he first time introduced the RD model with the flooding event. So basically in his framework the new thing was he was introduced a flooding event, and he came with a different rating and roughness model with a different type of percentage probability of flood risk for the future. He also introduced a framework for the same, how we can develop this deterioration model. So it's time to defining the pavement flood resiliency. So what is a resiliency? Is nothing but the ability of system to resist, observe, accommodate and recover from the effect of the hazard in a timely and efficient manner. So in a simple word I would say resilience is nothing but the ability of system to bounce back to its original functionality after the disruptive event in an efficient manner and a timely manner. So as you can see in this graph here, green line represent the resilient pavement and the red line is non-resilient and the blue line represent the hardening system. So the green line system represent the fastest recovery than any other two systems. So I want to more clarify about the pavement flood resiliency by one example here with the regular pavement and the resilient pavement. So as you can see in this graph, the red line represent the resilient pavement and the green line represent the regular pavement system. So the performance loss for the resilient pavement is very low compared to the regular pavement, and you can see the time span A represent time taken for the road for the closure after the event, and after the road closure is gained to its original functionality in very short time period C. On the other hand, time span B is more than time span A and time span D is more than time span C. So what makes a resilient pavement recover so fast? Why the time span C is so small than the time span D is really important to know here. Because we have made certain decisions by the post-flood maintenance strategies for this resilient pavement in the past, so that we have good amount of resources available already. We have prepared for the good resources for the treatment. We have already planned for the treatment, and we have found a suitable material for this treatment, so we can get the fastest recovery than the regular pavement. However, in a time span F, for the resilient pavement, we have already made few pre-flood maintenance strategies. So we are strengthening our system to be a flood ready for a future event, and that's why it has a very low performance loss and a fastest recovery than the regular pavement. So F is generally basically define the our philosophy about the pre-flood maintenance strategy, and the C time span represent the fastest recovery in terms of post-flood road maintenance strategies and resourcefulness. F section define the robustness and C define the fastest recovery and resourcefulness. However, if you see the regular pavement, the time span E represent after certain amount of time the regular payment is not capable of getting more recovery. So that's why it's time to rehabilitate it. And at this time, we need to plan everything, what type of treatment it should require, what are the resources we need, and what are the maintenance strategies required, and all that. So that's why it takes larger time uh, in time E, in time span E, compared to the resilient payment. So in 2017, Khan introduced one framework how we can know which payment is flood resilient. So basically, in his framework, we can know that which the payment with the different loading condition and the strength parameters, different strength condition of the structure, which is less impacted by the, so in this performance indicator is roughness, so which one is a more flat curve, and that's introduces us the flood resilient payment. So as you can see in the graph, the red lines indicate a very flat curve, so that's why it is less impacted by the flooding event. So in this case, rigid payment is more resilient than those composite and flexible pavement with the given traffic and structure strength condition. So far we have talked about uh, the flood resiliency, defining the flood resiliency, and but now we have to talk about framework for the O&M strategies for the pre and post flood. So in 2017, Khan introduced the post-flood road maintenance strategies and the framework, how we can get the good maintenance strategies within a given budget, and which is to occupy the to minimize the uh, roughness. So in this framework, Khan introduced different treatments with the different standards. So eventually, as an output, we will get the best treatment with the best standard for the given uh, roughness index. He also introduced the pre-flood road maintenance strategies. So in his these strategies, he introduced a framework. So it is more similar like a post-flood road maintenance strategies, but in this context in philosophy, we have a very good maintenance strategies already prepared before the disruptive event is going to happen. So we have already made our system so robust. So as I explained before, it less robust, the more robustness is eventually a less performance loss and faster recovery. So far we have talked about the O&M strategies, but it is also important that which kind of material we are using and which technique we are using is also important for the flood resiliency, that define our flood resiliency of the pavement. There are so many flood resiliency material that can be used for the treatments, but I would like to talk about the FBS, form bitumen stabilization, because it has its own benefit over the any other stabilization techniques. The suitability of this FBS is first recognized by the in 1956 by Professor Ladis. Um, it has a very good benefits over any other stabilization technique because of the first is the environment friendly. We can use 100% recyclable material of asphalt. It's waterproof, so it's good for the flooding resilient. Um, it can be constructed in adverse weather conditions, so we can get the fastest recovery after the flooding incident, and we can open the road as soon as possible. And it is a strong and flexible to resist the fatigue and sinkage cracks. and the curing time is very less. As I mentioned, we can get the fastest recovery, economically viable, uh, huge cost construction saving, and it has a longer durability. There is one case study in Australia by using this FBS, and in 2015, Warren and Fisher said that FBS stabilization provided Queensland flood recovery a sustainable solution for the payment management. So basically, in this case study, what they have done is they have stabilized the lime uh, for the subgrade, and then later on they introduced the form bitumen stabilization work and the final product. They've also used the geotextile before introducing the sealing on the surface to make it more fatigue resistant. So yeah, in this case study, they have first proposed 2% of blend cement GEB as a secondary agent in FBS, but later on they have found that in a past project that um, it it leaves some cracks um, in the base layer, so that's why they have replaced it with 9% hydrated lime. So new design is 7% of bitumen, form bitumen plus 9% hydrated lime as a secondary agent plus binder. There are a few success stories of FBS, and they have worked really fine, and a few of them are already have been tested in a flooding condition, and they are still working and sustaining very well without any delay. And few of them are been constructed with 100% using of recycled existing material. And yeah, efficiently every projects are working very well. So I'm going to wrap up my presentation with for conclusion here. So as a beginning, we know that there are very severe disaster that happen that destroy the community, economic of country, and everything. Our road payments. We should lesson learning from that, and we should look forward for the flood resilient payment to efficiently preserve our road networks. We have also conclude that the RT models are really important, and with the flood risk for the payment management system incorporating natural disasters, and if we calibrate those RD models and we can introduce in our policies and guidelines, so that will be really helpful to preserve our local roads. So far we have talked about pre-flood and post-flood O&M strategies. They are really important and they play a vital role to make our road payment flood ready. And this maintenance philosophy is essential part of the PMS incorporating natural disaster like flooding. And we have also concluded that form bitumen stabilization is a remarkable option than any other options of rehabilitation techniques for the pre and post flood rehabilitation to achieve the robustness and speedy recovery. Those are the references I used for my presentation. And that's it. Thank you so much for listening me.